Hello. So a friend of mine recently asked me to make a redstone repeater circuit. So I made it here. Over here is going to be the undelayed side, and over here is going to be the delayed side. I made them both red, of course, because it's supposed to be redstone torches. So you click this on. After a while, that turns on, and then it turns off. Um, so it may seem simple, but there's actually a lot of weird issues with trying to cause a delay in a circuit. You actually need a lot of nonlinear components, uh, which, for reference, like resistors, whatnot, a capacitor even here, is all linear. So instead, we need stuff like an operational amplifier, and over here is a 555 timer, which has a bunch of operational amplifiers in it. So how does this work? So here we go. You'll notice at the top we've got this is an operational amplifier component. Now, what this is doing is we have a bunch of circuitry here and beyond and whatnot, and we have this. This is the switch and an indicator LED for the input. Now, we don't want all of this, or even all of this. We don't want these two things interfering with each other. So all this does is takes whatever signal is here, copies it over to here. Now, why not just connect them directly? Well, because this capacitor and this resistor here, even all of this, is going to mess with this retroactively. So we don't want that. Now, what's next is we got this. This is a capacitor and a resistor. Now what happens is, this is a digital input, it's just going to be on or off. So if you think about it from a voltage perspective, it's just going to be maximum voltage or minimum voltage. Now what this capacitor does is it takes that, and if it's down low and you apply a maximum voltage, it ramps up and hits the top. And if you then just turn it off, then when it's full, it'll just slope downwards until it hits the bottom. Now this is very useful for creating delay, because this part, this is only part of the 555 timer here. There's actually much more it can do, but we're just using a certain part of it. So what this is this takes 2/3 of the voltage from the top and 2/3 towards the bottom. Let's do it on the other side. And if it's going up like this and it hits this on its way up, then it toggles on. Now, if it's already high and then it goes down and hits this lower line, which is 2/3 towards the bottom, then it goes low. So this is a way of taking this slope and making it a digital signal, which then goes into an SR flip-flop. Now, some of you might know that that is a memory circuit, but it actually has a couple other uses. In this case, we're using it as a toggle. Now, one other thing to mention is that normally we put it on the actual output, but when I put it on the actual output, it goes low after a delay from a high input, and it goes high after a delay from a low input. So we actually want the opposite. So I ran it through a NOT gate, which is this long circuit at the end. But to show that, I just drew like an inverted output, because that's much simpler. And